Thank you very much, Judy. Good morning, everyone. I really would like to thank you very much for coming to this presentation. Maybe if you don't have to stay there. Maybe you can sit there or something on the ground. There is a lot of space here. So I really hope you will find this presentation useful, and maybe I hope also you will learn something. So my name is Robert Feranec. I'm from Federal Academy, and today we are going to speak about how to design boards that work the first time. Now, what does it mean, boards that work the first time? These are the boards which, when you receive your very first prototype, you connect it to power, and it just works. Yeah? These are the boards which, when you receive your prototype, you test it, and you can sell it to your customers. Now, why this topic, right? Why I choose this topic? There are much more popular topics like EMC, EMI, high speed, all this. But we already have awesome speakers on this summit. And I was thinking what else I could speak about. And I come up with this idea. Can you hear me? Oh, OK. And I come up with this idea. The thing is, not many people speak about these kind of things. And I believe they are important. You know, when you design or when you create a mistake in your schematic, the result may be exactly the same as if you make mistake in your high-speed layout. Yeah? Your board may not work. And in this presentation, I would like to point out some of these topics which you normally may not think about, but I believe are important. Now, you may be asking, why should I listen to this guy? Yeah? That's an excellent question. I cannot convince you that what I'm going to say is right or something. But what I can do, I can speak a little bit about what kind of boards I have designed, and I can speak about some of the procedures and steps which we use during the design process, and then you can make your own opinion. So I've been working on a number of different boards. I have designed boards based on ARM architecture, based on x86, but also different architectures like MIPS. Usually, I use chips from manufacturers like Intel or AMD, Texas Instruments, NXP, or Freescale. It does not really matter. I think what is really important for you is that many of these boards were really, really complex. For example, one of the most complex boards what I have designed was based on Intel Atom processor and also Intel i7 processor. And I need to say that many of these boards what I have designed, they were sold to customers as version 1, issue 1. Yeah? And OK, some of them were sold as version 1, issue 2 with some adjustments. But I mentioned this because I have designed a number of these boards, and maybe there really is something in the steps, in the procedures which I use, what really can help you to design boards that work the first time. And that's what I would like to share with you today in this presentation. I prepared 12 tips or 12 points which I believe can help you to design boards that work the first time. So the first tip or first point, what I would like to speak about is import reference schematic. Now, you may think like, oh, maybe I'm on wrong presentation. I already know this. Yeah? So what's the big deal about importing reference schematic? Some people, or very often these reference schematics, they are in a PDF format. And some people, they don't know. You can contact the chip manufacturer or the supplier and ask for the source files of the schematics, and you can get them. Okay? Sometimes it depends what is the size of the company where you work, because maybe if you are a Google employee and you ask for a reference schematic, you will probably get it. You will probably get any schematic if you are a Google employee. If you work for smaller company, sometimes it's a little bit harder, but always try it, okay? Ask for it. It's, don't forget, chip manufacturers, they would like to sell the chips. So it's in their own interest to support your development, usually. Yeah. So what is so important about importing reference schematics? Do you know? The first thing is, many people import reference schematic because it saves a lot of time. You don't need to redraw it. And when you redraw schematic, you can make mistake in connections, or you can make mistake in net names. Yeah? And this is what is the big advantage of importing reference schematic. It minimizes number of mistakes which you can make in your project. Yeah? Basically, when you import reference schematic, you are 100% sure that you are starting from something what really, really works. And this can increase the chances that the board what you are designing is going to work the first time. The point number 2 is use the same pinout and connections as in the reference circuit. This may be a little bit more specific for digital circuits, which I normally design, but you know, today almost every board has at least a microcontroller. So it may apply also to your project. The thing is, one pin, very often, one pin can have a number of different features. And not only this, very often, one feature can be mapped to different pins. Now, if you are importing reference circuit, so if you don't have to, do not remap features to different pins, or do not remap pins to different features, just because, I don't know, you would like to have it on different pin. Yeah? Especially if these features are used in the reference schematic, and if you need to use them in your design, don't do it. So for example, if, just I give you an example because that's always the best. Yeah? So for example, if in this design, or if in your design you are using UART1TXD signal, and it is in the reference design mapped to the pin M1, then you really don't want to map it to different pin in your own schematic. Yeah? What do you think? What is the reason, or what are the advantages of staying compatible with the reference circuit? Do you know?
Software.
Exactly. One of the biggest advantages is faster software development. Yeah? Any differences you do from reference circuit can slow down software development. If you incorrectly map a feature to a pin, or if you map a feature to different pin, you may spend a lot of time by updating drivers, updating software, and sometimes it may not even work. Yeah? So the second advantage, staying compatible with reference circuit, is you can also use the firmware from the reference board. And this is very, very important, especially when you are connecting your board to power for very, very first time. Yeah? Imagine that you make many, many changes in your schematic. Now you have to update the software. You have to compile the software. You have to generate binaries. You have to flash these binaries to your board. And now you are going to switch it to power for very first time. Yeah? And you connect the power, and nothing happened. So where is the problem? Yeah? Is the problem in the software, or is the problem in the hardware? And sometimes there is problem in software and also in hardware, and it's getting much more complicated. So if you don't have to, do not. The third thing what I wanted to mention is, was there the third thing? Yeah, there was the third thing. Third thing was that when you use, or when you are very close to reference circuit, you know this circuit 100% work. Yeah? So same as for the importing schematic. If you don't have to do not break the reference circuit, this will help you to design boards that work the first time. Tip number 3, or point number 3, build simple test circuits. Once we needed to design a circuit which would automatically switch power input between jack and USB connector. And the schematic looked quite simple. So we created the PCB and we tested it. Yeah? We tried the board and nothing happened. Yeah? Or it worked somehow, but not as we were expecting. So what we had to do, we needed to update the schematic, and we created new board, second version of this board. We tried it, and again, yeah, you can guess. Yeah? So it did work somehow, not as we wanted. We needed 4 revisions of this simple board to get exactly the result, to get the behavior of the circuit which we needed for our board. Now imagine that you are doing these experiments on your big board, on the board with many components, with complicated PCB, and on the board which cost a lot of money to build. Okay? Imagine that you would need to create 4 revisions of your board just to get this simple circuit right. Yeah? Now, I'm not saying that how this is going to show how good the engineer you are. Yeah? Your boss, your client, they may not really like so many revisions of the board. So if you have to design a board from your head, or use a circuit, or if you need to design or use a circuit from your head, which you never used before, maybe you really should consider to create 1 or 2 layer PCBs to test it before you use it on your big board. Yeah? This can save you many board revisions. This can save you, or this can help you to design boards that work the first time. Tip number 4, point number 4, add bypass resistors, pull-ups and pull-downs, optional components into your schematic. Sometimes you cannot build test circuit because you need the signals which are on your board, on the board which doesn't exist yet. Or sometimes you don't want to build test circuit because it's not necessary. You just would like to know if you have to use pull-up or pull-down resistor, so you are not going to create test circuit for this. So what you can do? You can just add some extra components into your schematic. It looks simple, but I still can see many boards where people need to wire up a pull-up to a pin, or they need to cut a trace on PCB. Yeah? It's not necessary. Just add a couple of components. For example, let's say, I don't know, let's say, again, I give you an example. Let's say, oops, I would like to connect this watchdog output, and I'm not sure how this watchdog output signal is going to work when I'm creating the schematic, because you need some software support for this. So what you are going to do? Just add 0-ohm resistor, and if needed, do not fit the resistor. You don't have to cut the traces on your PCB. Yeah? So it can help you a lot. And it doesn't have to be only this 0-ohm resistor. If you are not sure about pull-ups, pull-downs, I'm pretty sure you already do this. Just put there both footprints, try the pull-up. If it doesn't work correctly, put there the pull-down. Very often I use resistors to reroute some signals on the PCB, or even bypass some circuits. Same as for building the boards. Sometimes you need to add a circuit which you never tested. So In this situation, I always put there 0 ohm resistor. In case there is problem with this circuit, you can just bypass this circuit. And yes, okay, you will lose the feature of the circuit, but you know, everything else on your board still can work just perfectly fine. So you can sell it to customers even without this one feature. It's not a problem. These extra components can help you a lot. And in many, many projects, there is plenty of space on the PCBs. You can simply just add some unfitted footprints. You can simply add a couple of 0 ohm resistors. It's just fine. It's no problem. But it can help you to design boards that work the first time. Tip number 5, check, double check. I will go to the picture. Check, double check, and triple check your libraries, yeah? Do you remember the times when we were starting with hardware design? I do remember mine, yeah? This is demonstration of my soldering skills, and not only that. So, bad libraries are one of the most common mistakes, and one of the hardest to fix. And there is bad footprint, you have to redesign the board in many, many cases. The thing is, why this is happening? Because you have all the information about the component. You know exactly how it looks, what is the size of the component, what is the pinout. Yeah? And still, people do mistakes in libraries. So what we do at Fedevel Academy is, I'm going to explain a little bit what we have 3 main things what we always do at Fedevel Academy. And the first thing is we always buy the components when we finish the schematic. Yeah? Some samples of the components. You don't need to buy thousands of the components. So samples of the components when we finish schematic and when we start doing the layout. What is the advantage of having the component? One of the advantages is you check the manufacturer part number and supplier part number. Yeah? Whoever had a colleague, or maybe even you, who ordered thousands of pieces of a component in wrong footprint? Yeah? Yeah? It doesn't have to happen. Just when you finish schematic, buy a couple of components, samples, and you will be sure that when you are doing mass production, you will get exactly the component which you need, and it will be in the right footprint. And that's not all, because the second thing, what you can do, once you have the component, you can always also check the footprint. Yeah? So that's the second very important thing, what we always do at Fedevel Academy. We always print the footprint on paper, and we compare it with the real component. And very often, it's just fine. But sometimes it's wrong. Usually, sometimes we also adjust the footprint because, I don't know, seal screen is too small, or we would like to have a little bit bigger parts for better soldering. So this is very useful. I remember when I used to work in a bigger company, some people, when I was cutting out these footprints from paper, some people, they were smiling. Yeah, what are you doing? We are playing. But I will rather be cutting footprints from paper than telling my boss that, hi, we need to redesign the board, we need to build new revision because this memory chip is not going to fit. Yeah? This really happened, one of my colleagues. So I will rather cut out the footprints from the paper than telling this my boss. The third thing what we always do at Fedevel Academy is we check the pin ordering. Yeah? Especially since one special time, I always check the pin numbering. Do you know what is wrong on this one? Yes, exactly. Most footprints, they start pin numbering from the top left corner. Yeah? This one starts from the middle. It's like, ugh. So always when you when you finish your schematic, you may find it very, very useful. Buy samples of the components which you are going to use and check them before you send your PCB into production. It can help you to design boards that work the first time. Tip number 6, go through schematic check and layout check documents. Not every company provides this. However, these documents can be useful because inside these documents you can find information how to connect pins of specific chip and how to route these pins. Yeah? Here are examples of these documents, so you can see what you can find inside. Here on the left, this is the schematic check document. And for example, you can see here, you can see here that the chip manufacturer, they recommend to connect this gigabit TX signal to Ethernet transceiver TX pin with 22 to 33 ohm series termination resistor. This, on the right, is PCB check document. And you can see, again, chip manufacturer, they tells you that when you are connecting this pin, you should place the termination resistors within 1 inch from the source pin. It tells you also that you should route it by 55 ohm impedance and length measure it within 300 mils comparing to the other signals in the same group. So it can be very useful. Next time when you are designing a board and you need a new chip, what you may want to do, always check documentation of the chip manufacturer. And maybe you may be looking for these schematic check and layout check documents because they can help you to check your schematic and check your PCB. And they can help you to design boards that work the first time. So tip number 7, take time to browse and check your schematic. Maybe this is going to now change because of Ultimate In. It's going to be black. So this is absolutely the most important tip from all. Yeah? Every single time I'm checking schematic, I will always find something what is wrong, what needs to be fixed. I always find something what can be improved. Now, I would like to ask you, how many of you check your schematic? Yeah? Everyone? Awesome. Now, tricky question. How many of you spend a week or more by checking your schematic? Normally, I spend 2 to 3 weeks by checking symbols, footprints, and schematic. Yeah? And Altium has this awesome feature, which is called Navigator. And I can tell you, even when I'm designing in different CAD system, like ORCAD, always when I finish the schematic, I will import it to Altium because I can use this Navigator feature to check it. So a little bit about the Navigator. Here what you can see, this is the Navigator panel. In the panel, you will see or you will find 4 lists. The first list is a list of pages in your schematic or in your project. The second list is list of, or at least in Altium 17, yeah? is list of components. Then there is a list of components which are connected to the selected page. Yeah? This is important. So here, in the next list, you will find a list of nets which are in the selected page. And in the last list, you will find a list of pins which are connected to the selected net. Now, when you click on the page or component or pin or net, you will always see it in the schematic window. It's very important that you realize how useful this is. Yeah? It doesn't matter how big or how complicated your project is, your schematic is. You can always break it down to the pin level. And you can always go through every single net in your project and check it one by one. And this is how we do it at Fedevel Academy. First, I decide on the schematic page which I would like to check. So I will select it. And then I go and select the first net in this list. Once I select the net, I go down here and I click on every single pin and check if these pins can be connected together. I will give you an example. Again, examples are always the best. So let's say I have selected here UART TX net. So there should be at least 2 pins connected to this net. First will be called UART TX. The other one will be called UART RX. Exactly. So see, you checked the connection. Different example. Let's say I'm checking the I2C clock signal. Yeah. So I selected here. Here will be bunch of pins. Most of these pins will have a name which will be called something like I2C, clock. Yeah. Now, you may be surprised how many times I found mistake that instead of I2C clock, the I2C data was connected. I see many of you had same issue, or you noticed same thing. The problem is because some components or some symbols, they have I2C interface, and they may have the clock signal on the top and data signal on the bottom. The other one can have data on the top and clock on the bottom. Now when you copy and paste the net names, you forget to swap them, and it's a mistake. So this can be very helpful. Now, and it's not only this. Always when I'm checking schematic and when I select a net and I go through all the pins, then I will ask question like, am I sure that this net is going to 100% work? Yeah. You select only one single net, so you focus on this net and you ask this question. If your answer is no, then there is something wrong in the schematic. Yeah? So you should try keeping improving the net until you are 100% sure it's going to work. Now, the thing is, when you go through all nets in your design and you are 100% sure that every single net in your design will 100% work, then it makes you feel quite confident that you have done everything what you could to make the design or make the schematic as good as you could. Yeah? It's very, very useful. Many board revisions are created because there is a mistake in the schematic which, if you see it, if someone shows you this is the mistake, you would immediately fix it. Yeah? So checking schematic can really help you, proper schematic checking can really help you to design boards that work the first time. Tip number 8, once placement is ready, build a paper model. Many of you may be seeing this picture. I use it a lot. This is another very, very useful tip. It saved me so many times. Very similar as for schematic checking. Every single time we create this paper model, we always find something what needs to be fixed or what can be improved. When I say paper model, it means you just print your PCB on a paper, you glue it on cardboard or something, you put there connectors and maybe some big components. Yeah? Now you may say like, but, why this is useful? Do you know? It can make you feel confident that when you send your PCB into production, that everything is going to fit. Yeah? It makes you confident that when you receive this board, everything will be where it should be. Now you may say like, but I don't need paper model because we use 3D models. 3D models are awesome, but they are not universal for everything. For example, in 3D models, very often you do not include mating connectors. Yeah? And having this experience when you can like plug in the connectors, or you can try to mount this board into system or into enclosure, it can be very useful. Paper model is a very simple way how you can check I don't know, mounting position of mounting holes or position of the connectors.
Your fingers trying to connect them in there.
I sometimes mention this. Have you ever had the laptop where you try to plug in two memory sticks and you couldn't fit it because the USB connectors are very close to each other? Yeah, I had one too, maybe even two laptops like this. Maybe they didn't build paper model, yeah? I'm just kidding. Okay. No, we always create the paper model when we finish schematic and when we do the placement. I remember when I was starting with hardware design, every time when I sent PCB into production, I was very nervous, yeah? And then every single time when our phone rang, I was like, I really hope they are not calling from the assembly house, going to tell me something is not going to fit, yeah? So you don't need to have this feeling, yeah? You can kind of build the board before you send it into production. You can create this paper model, and it can really help you to design boards that work the first time. Tip number 9, reuse reference layout. When I was starting with hardware design, I didn't feel confident in doing layout of interfaces such memory, yeah? And I was worried, if I make this layout wrong, whole board is not going to work. And I was right, yeah? If you do it wrong, your board may not work. So what you are going to do? What I've done, I took the critical layout from the reference board and use it in my project, yeah? And the board worked. Even I have never designed so complicated layout before, it just worked. So always when you have this feeling like, I'm not really sure about how to do this layout, and if you can, then reuse the layout from the reference board. Don't forget, we all have to learn somehow, yeah? We cannot just jump from designing LED circuit and then designing motherboards. And you can learn in steps. So in first project, you can, for example, copy the whole memory layout from the reference board and use it in your board, in your project. In the second project, you can copy the reference layout and make some changes. And then in the third project, maybe you will feel confident enough to make whole layout all by yourself. And it's not only about the memory layout. There are also some other circuits or interfaces which you may want to have a look how they have done this layout on the reference board, and maybe you can use exactly, or maybe you would like to use exactly the same layout or similar layout on your board too, like circuits like, I don't know, power supplies or fan out of a BGA or antennas, yeah? Especially in cases when you are designing a board with interface which you have never used before, you really may want to just copy the layout from the reference board because it can help you. Yeah? It can help you to design boards that will work the first time. Tip number 10, read and follow design guides. I love this point. Yeah? Design guides helped me a lot, especially when I was starting with hardware design. Yeah? I left university with almost no practical experience. And my first job was to design a board which was running operating system Linux. I had no idea how to do it, yeah? Don't tell anyone. Design guide helped me a lot. I followed design guide, and by following design guide, I was able to create the schematic, and I was able to make the PCB, yeah? And the board worked. So good design guides are awesome for learning. I really love design guides from Intel. They have really, really good design guides. Many people ask me how I learned to design so complicated boards, what kind of book I would recommend to them. And I always tell them I learn a lot from design guides. So next time, again, when you, similar as for the schematic check and PCB layout check documents, next time when you are deciding what kind of chip you are going to use in your project, have a look at documentation. Check if they have design guides, because design guides are going to help you to design board that work the first time. Tip number 11, if during layout you have to break important rules, simulate. Yeah? This is a very interesting point because normally I do not simulate. However, I do consider running simulation of your board important, especially in cases when you do not feel confident about the layout. Yeah? These are the situations when you need to break important rules or too many rules from the design guide. Yeah? These are the situations when, for example, you need to route signals of memory interface too close to each other, or you need to place more chips on one bus, and you would like to be sure that the signal quality on the pins still will be okay. Yeah? I remember a couple of times when I've done simulation, I actually completely redone the placement and the layout because the results from the simulation were disaster. Yeah? And I believe simulation saved me from having to design new board revision. So if you do not feel confident about the layout which you have done, try to run simulation. Yeah? It can give you the confidence if it's going to work or if you need to do some changes. It will help you to design boards that work the first time. Tip number 12, imagine what will happen when you connect your board to power. Imagine what you are going to do when you receive your first prototype. Always when I'm creating schematic, always when I'm creating schematic, or when you are creating or checking schematic, you should have a look at your board from different views. Yeah? For example, when I'm checking schematic and I'm checking this particular pin, this is something what I call pin view. Yeah? This is the view when I'm looking if input is connected to output, or if all the required pull-ups or pull-downs are connected to the net, or if, for example, all the pins are running on same net or same voltage level. Yeah? This is what I call pin view. Then there are different kinds of views, like interface view. Yeah? I have a look on whole interface, and I'm thinking if all the nets which should be inside the interface, if they are all connected. Like if you are checking a memory interface, you are looking if all the address signals, command signals, control, and data signals are connected in this interface. And one of the views, what I always try to imagine is what is going to happen when I connect power to my board. Yeah? How the power supplies are going to be switched on, in what order, how the board is going to reset. And it may look simple, but for complex boards, this is very important. And not only the order of the switching the power supplies, but also you need to think about the situation when some of your board is switched on because some of the power rails are on and the rest of the board is still switched off. You may be surprised how many boards will occasionally not boot up because of this problem. Yeah? Leaking current between power supplies, between the part of your which is on and the part of board which is off. Different kind of view, what I always try to imagine is that I receive my board. I have it on my table, and now what will be the next steps? What I'm going to do? For example, how I'm going to put firmware on my board. Yeah? It's not it may be not best situation when you receive your board and you find out you forgot to place the JTAG connector. Yeah? Or maybe JTAG, I see someone is raising hands. So maybe that's extreme. I wanted to say maybe that's extreme example, but I see it's happening. So it's not maybe not so extreme example, but there are also chips They can be smaller chips, like power management chips, and they may need some little piece of firmware. So what you may think about, maybe place some test points so you are able to refresh or update the firmware. And it doesn't have to be only connectors or test points for firmware programming. You also may want to think how you are going to test your board. Yeah? So you may want to add circuit for testing and debugging. Or you may want to add some resistors because you would like to try different boot modes. Yeah? Booting from SATA drive or SD card or SPI. It may look like not important, but it's very, very important to imagine what you are going to do when you receive your board. Because this can help you, like you can guess, to design boards that work the first time. Now, I'm almost finished. So during my career in hardware design, I have seen many reasons why new board revision had to be created. Many of these things are usually like missing pull-up or pull-down, mistake in footprint, or the changes with what people needed to make very quickly, and they just forgot to check it, properly check it. Yeah? And you know, so what we can do about this? Yeah? These are the mistakes, what I call beginner's mistake, okay? I remember the time when I was like 15, and when I was building this 555 circuit, you know, the LED flashing circuit, and the circuit was like maybe 10 wires, and I created there maybe 20 mistakes, yeah? I spent whole afternoon trying to figure out why the circuit doesn't work. When you are designing complex boards, you cannot make 20 mistakes in 10 nets. Yeah? When you are designing boards with thousands of components and 10,000 of connections, you cannot make silly mistakes. So always when you are designing boards, take your time. Do not try to rush the development. I know your manager, they will tell you like, we need the board as soon as possible. But you always need to try to explain that maybe rushing the development can, you know, can make some mistakes, yeah, and it may not be really the best way to do it, yeah. So that's what I would like to say. Always when you are designing board, take your time. Think about the work, what you are doing, and check the work after you. We are almost done. I would like to just ask 2 questions, if I can. First, I would like to ask if here is someone who ever seen my video on YouTube. Awesome. Thank you, guys. And is here someone who ever actually bought some of our courses? Oh, thank you so much, guys. So yeah, if you would like to learn more about hardware design, or if you have some employees what would like to learn about hardware design, you can just Google for Fedevel Academy. I have created a number of free videos on YouTube, but we also have online schematic design and PCB layout courses. So if you have any questions, or if we have some time, I don't know, you can ask now.
I have a question. On some of the dry fitting, like buying the part and putting on the 1-to-1 scale of the paper, I've had customers say we don't want to buy the samples because the data sheets are good. Just go by the data sheets. Have you found out when you talk with customers that they're on board with that, like buying some samples?
Yeah. So the question is, what if your customer doesn't want to buy the samples of the components? I will always try to explain them that it's for, you know, the project cost is usually huge, and just buying few components is not so huge cost comparing to the benefit which you can get from having the components.
About 20 years ago, I tried a laser printer to circuit board etching transfer. And I found that there was a fair amount of inaccuracy in the sizing. It wouldn't work for fine pitch at all. Have you seen much of that? Is that greatly improved?
So you mean like when you print, for example, footprint on paper, there may be some inaccuracy? Yeah, that's happening sometimes. But we found same problem too. But you know, when you compare the real component with the footprint, you still may be able to say if it's going to be right or not. It's sometimes, usually, it is a little bit bigger, I think, what you print comparing to real component. Yeah.
Etching.
Yeah, for etching, it may not be good enough. But for the comparison, it can be just fine. So shall we have like one more question? Or I don't know what is the time?
We probably need to wrap. But you could ask Robert questions perhaps over lunch. I have a quick couple announcements before you go just to keep you on track. We're trying to catch up on some time. First of all, thank you, Robert. Good job.
Thank you.